to all of you. Today we will talk about the smart grid elements and technology. First in this lecture, I will discuss about the advanced metering infrastructure. Coming to this AMI basic block diagram, if you will see here that it consists of 3 components. The first one is the MDMS. This MDMS stands for Meter Data Management System, and the second one is the smart meters, which is basically located in the consumer's periphery or premises, and this MDMS basically present inside the utility DCCs, and this is the data control centers, which is basically present at the periphery or the premises of the utility. And these 2 components, these 2 blocks, this MDMS and smart meters are connected with each other, or they communicate to each other with help of a communication infrastructure. So, this is how this very basic block diagram works as far as the advanced metering infrastructure of the smart grid system is concerned. This is a very important component, or you can say technology of the smart grid system. And apart from this AMI, we have also AMR. This AMR stands for automated meter reading. What is the function of this AMR? This AMR systems allow meters to be read by utility personnel over wireless links. What is the meaning of this? Basically, inside the customer we have the energy meters, we have the smart meters. So, those smart meters readings we have to read, we have to collect the data from those smart meters. So, for that purpose, this automated meter reading system allows, if suppose any personnel will reach near to the customer premises. So, from there itself by wireless communication we can read the data of the meter, which is basically located inside the customer premises. That is what this AMR does. Now, also with help of this wireless communication of this smart meters to the AMR system, we can reduce the cost, because it is a wireless medium. If it is wired medium, so it will demand more cost. So, that is what it helps in reducing the cost associated with the meter reading and also support the billing process. Automatically the smart meter readings will reach to the person. That is a very great benefit, great technology, or you can say great facility as far as the smart grid is concerned. Now, the next we will talk about what are the measurements we basically obtain from the smart meter. The first one is the RMS voltage, and the second one is RMS current, and third one is phase angle measurement. This phase angle basically we talk about the angle between the voltage and the current of the particular network or customer network where the loads are connected. So, this phase angle also measured with help of this smart meter. And the fourth one is the power factor, which is very important for us. As far as the customers are concerned, the power factor has a great meaning. So, this power factor can also be measured with help of the smart meter. And the fifth one is the instantaneous active power. How much power is basically consumed by the customer, that can also be measured using this smart meter infrastructure or smart meter device. And the sixth one is the instantaneous power, reactive power. So, we have 2 powers basically we are talking about here. One is the instantaneous active power and the next one is instantaneous reactive power. So, these 2 powers we can also measure using the smart meter technology. And the last one is the energy consumption, which is very important for us, for the utility, also for the consumers. So, how much power, how much energy is consumed by the customer, that is our target. So, that particular energy can also be measured using this smart meter, that is basically the target. So, extra parts what we are getting here, this RMS voltage, current, phase angle, power factor, this instantaneous active power, reactive power. So, those the fundamental quantities or the derived quantities we can use for further necessity, we can use for further actions. That is what the very important benefit or advantage of smart meter. We should use, we should encourage to the customers, they should be trained, they should be encouraged to use smart meters inside their premises. Now, this is the networking for AMI. We are talking about presently the advanced metering infrastructure of the smart grid system. As far as the network of AMI is concerned, you can see here I have just taken two figures, two sections basically, figure A and figure B. What is this figure A? The figure A tells that the meter, the smart meter is connected directly to the data control center or to the MDMS. So, which is, this is the utility side and this is the customer side. So, this meter, basically these two devices like meters and the DMS are connected using a dedicated communication network. So, this kind of fashion of architecture or infrastructure is known as meters connects directly to the utility MDMS type. It is a direct connection. And the second one is the vendor proprietary AMI solution based connection. What is that? In this case, if you could see here from this figure that here there are more number of smart meters basically which are connected to the meter concentrator, and again through the communication network they are connected to the MDMS of the utility section. This is this architecture, this configuration is different than the earlier one. And we will talk about more all the component, what are the functions of each components. Now, if we will come to the first one, meters connected directly to the MDMS system. What is the function? Here that each meter communicates with MDMS over a communication network, that is the first requirement. And the second one, these interfaces connect to the utilities wireline or wireless communication network or NSP broadband network to provide connectivity to this MDMS. And the third one is there may be also the communication network, it is IP type, internet protocols. So, through this type of communication system also the smart meters are also connected to the utility side. Now, see in this case each meter is assigned one particular IP address and those rules are basically written in this standards, ANSI C12.19 and C12.22. So, these are the two standards where everything is written, that how this basically the meters are going to be connected to the utility side MDMS. Now, the second solution, that is the vendor proprietary AMI solution. In this case basically we have more number of vendors are associated, and that is why we have more number of smart meters present, if we will compare these two figures. Now, these meters basically again they are connected to the meter concentrator through a NAN network. You know, this NAN, neighborhood area network, is a network of the distribution site of the smart grid system. See, this NAN network, I mean the NAN, the neighborhood area network, is a communication infrastructure. So, this communication infrastructure allows to connect the information, the output of these meters to the meter concentrator. And again this output of this meter concentrator is sent to the MDMS or through this DCC router through a LAN. LAN means the local area network. This is also one of the communication technologies which is used in the distribution system. So, basically in overall if you see that what is the basic difference between these two, there is nothing, that here two things very distinguishedly it is different, that is first is the NAN and second one is the LAN. So, these two communication infrastructures are very essential when we will go for this second type of advanced metering infrastructure. And we will talk about that. I will just want to mention here one thing, that why this second one is essential. If we have the first one, why you are opting this the second one, what is the necessity? To be honest, this kind of structure, I mean I am talking about this AMI communication standards, and I am talking about this AMI deployment, and basically due to the lack of communication infrastructure and again the communication standards in the fancy stage and also in cost effective. So, for that reason the AMI deployment is basically based on the vendor proprietary. See, this is, to be honest, the smart grid technology is coming up. Those technologies are in pen and paper, we have to implement in the field in near future. So, and many cases also it is implemented, but in India we are hoping very soon we will see this kind of infrastructure. The smart meters are going to be installed at every corner of the house. So, that is essential, because otherwise our system will not be smart. To make the system smart, we have to install the smart meters. So, we will see the further what are the benefits, what are the advantages of installing the smart meter inside our home or inside any customers, I mean any type of consumers, maybe residential, maybe commercial, maybe it is kind of industrial. So, this is how these two infrastructures I have described here. Now, I will come the function of this NAN. This NAN is basically it is a communication infrastructure, and it may be a power line communication type, or it may be radio communication type, or it may also PLC. The PLC stands for programmable logic controller. Okay. So, this it looks like this, the PLC looks like this. Programmable logic controllers are basically used mostly in industries to control the machineries, the operation of the machines, and here also we can use the PLC concept by connecting the secondary of the distribution transformer to the consumer. So, basically it is a kind of wired or wireless communication system. So, this NAN helps in connecting, by connecting the smart meters to the utility section through this meter concentrator and communication network. And the next one is the smart meter. So, what is the smart meter function? The meters support a communication interface to connect this NAN, and this interface may be integrated with meter attached to the meters from the different vendor models. So, this is also important. This smart meter concentrator, what it happens, what we do here, smart meter, and this is the smart meter concentrator. This concentrator helps in connecting this NAN information to through this communication network to the utility side. That is a function of this meter concentrator. That is what I have just described in the previous slide, and this is what written here. This meter concentrator is responsible for supporting the communication with the meters over the NAN to collect periodic measurements. This is important. It may be within 5 minutes, 15 minutes. So, that periodic measurements and alarms generated at the meters as well as send the commands or send the DMS to the meters and receive corresponding responses. I want to explain further this point. What is the function of this meter concentrator? Basically, first of all, this meter concentrator will collect the information from the smart meters through this LAN section, this NAN section, and again this meter will send the data to the MDMS, and also the reverse side. What is the reverse side? This MDMS will send the information or data, whatever the things we need in the operation of the smart grid system. So, this will send to the meter concentrator. Again this meter concentrator will react, I mean it will just send, or I mean it will just convey the message to the smart meters through this NAN communication infrastructure. So, this is a two-way communication. The two-way communication means the smart meters will speak to the MDMS system and the MDMS system will also talk to the smart meters, the two-way communication infrastructure. And coming to the what is the function of head end? You could see here it is written head end. We already discussed what is MDMS, what is this LAN, and what is this meter concentrator, and what is this NAN and the smart meters. So, another element or device, that is head end. This head end is the AMI solutions meter management system. It manages the AMI solutions meter. Whatever the data or information we exchange between the smart meter and this utility MDMS. So, those exchange, I mean the data exchange should be managed properly. So, this data head basically does that. Okay. Now, the head end communicates with the meter concentrator over an IP connection provided by the smart grid. Basically, through this IP structure based communication system, this head end communicates with your meter concentrator. Now, we will come to the second technology, and where also we will talk about some components, right. So, of the smart grid system, that is our distribution automation system. So, as all of you know that the name itself suggests what? It is a basically automation system. The distribution system is basically automated as far as the operation is concerned, as far as the control is concerned, as far as the monitoring is concerned. It should be automatic in nature. That is what this distribution automation. So, this distribution automation refers the automation of all functions related to the distribution system. This automation is important. Using information collected from substation devices, deployed on feeders, meters deployed at customer locations. It is very easy. I mean the concept is very easy. What is it? That this distribution automation system allows to collect the data or information from the sensors which are basically located, or devices which are located at the consumer locations. And this basically consumers locations data are sent to a central computer center. We will talk about later that system. And this center computational system will receive all the data, all the information from the the devices or sensors which are installed at the consumer premises or consumer locations. And then by getting those data, by obtaining those data at the center place, so we can do our desired work. We can do we can take any action we like. We can do any offline study, we can do any online study, we can do online actions also. For example, we have one feeder. The feeder is basically, it is a, if you could see that if it is a substation and we have, let us say, 4 buses, and this is a feeder and these are the loads. If any fault is incepted, let us one line to ground fault is incepted in this section of the feeder, then particularly we have relays, protective relays to protect every section. So, if it is suppose say overcurrent relay means if the current, the set current, I mean the relay will see the current is beyond the set value of the current, the relay will react, it will just trip, it will give a trip signal to the circuit breaker. This is the circuit breaker, this is also one circuit breaker. The circuit breaker basically opens the section. So, if any fault is incepted in this section, the relay will receive the current through the secondary of the CT current transformer and it will send a trip command to this circuit breaker, and the circuit breaker will try to open that particular section. So, that means those relay information should reach to our central unit either from the relay or maybe the circuit breaker has one device. We will talk about the intelligent electronic devices. Those electronic devices are installed near to the circuit breaker and the circuit breaker status will be sent to the central controller to take some decision whether the circuit breaker is going to open or not. I mean from the remote place, I mean the circuit breakers and feeders are far away from the center place. The center place is the place where we have to take some action by gathering the information from the relays, from CTs, from PTs. So, it depends, see this, that is what the meaning of smart grid. In this smart grid era, with the availability of very advanced infrastructure of the communication system and very high computational technologies, signal processing technologies, we can do anything. Yes, of course, that should be cost effective, that should be very economic. So, to have very, I mean smart operation, very automated operation, we can design our technology for the smart grid system. So, that is for this the Scada system is one. Within this distribution automation, the Scada system is one which helps in monitoring and accusing the data and further controlling the equipments which are basically placed in the feeders, throughout the feeders. Basically the circuit breaker, the isolators, the reclosers, we have sectionalizers, so many components. Okay, so that is what this Scada systems, as I said, that monitors, controls the distribution substations and is considered as a DA function. This Scada system is treated as a DA function. DA means the distribution automation function. Now, more widely in broadly how to define this? In more widely, the definition of distribution automation is limited to the acquisition of data. It will accuse, it will collect the data from all the sensors which are located throughout the feeder or deployed on feeders or deployed at consumers location. So, this basically the distribution automation is limited to the acquisition of data measurements from IEDs. This IED stands for intelligent electronic devices, basically which are connected to the devices on the feeder and control of those feeder devices. We will see more about this, the infrastructure I have kept in further slides. We will talk about what is this IED and what is this, where it is connected and how it functions. This is how the architecture or the layout of distribution automation system. Here you could see this is my distribution substation, and this is our transformer, this is the circuit breaker, and this is one switch, and we have the capacitor bank. Basically, the capacitor bank is used inside the distribution system to improve basically correct the power factor and sometimes also to improve the voltage profile. The capacitor basically provides the leading current and it injects the reactive powers to the circuit. So, that is why sometimes we use also the, not sometimes, it very frequently the capacitor banks are used inside the distribution system. And we have also reclosers and we have distribution transformer. This is a substation transformer. The distribution transformer basically steps down the voltage to 440 volt level. If this is a 11 kV substation, so we have to step down to 440 volt. And these are the, I just said one term there, how this ID is connected. This, how does this ID connect to the system? This ID is present near to the distribution transformer or near to the switch or near to the recloser or near to the capacitor bank. It will collect the data from those devices. So, these are the devices which are basically present inside a distribution system. This is our this whole system is our distribution system and this is your distribution substation, from where we will get the power to the subsequent sections. I mean, this is our feeder, this is one feeder. Now, that means that every components or devices are basically, I mean every device is assisted with one IED, that is intelligent electronic device. Now, basically this IED will communicate through this communication network to the data and control center. This is basically the master control center of the distribution automation system, that stands for DA, master control. And also we have another section here, that DA data concentrator, that is alternate distribution automation data concentrator at the substation level. So, that also will speak to the master center through this communication network. Now, basically the recloser is one of the components of the smart grid system. And what is the function of it? Basically it monitors and breaks the feeder if suddenly the current magnitude exceeds the set value or certain threshold value or it exceeds the predefined value. Now, this recloser monitors and breaks the feeder current if the current exceeds a preset threshold. And remember, in power system the faults are basically temporary in nature. The tree will touch to the lines, again it will go away due to the wind, the tree will come, again it will touch, again it will go back. So, due to this, I mean the fault may not be a permanent fault, it may be a temporary fault. In that case, the recloser will again open the line, again close the line, connect, reconnect, I mean open, reconnect. So, that it takes some attempts to reconnect the circuit automatically after short period of time after disconnecting it. It takes some time, again it reconnects. It will I mean several predefined times it will do, and it will conclude, before concluding that the fault is permanent. Now, in the event of recloser declares a fault permanent, then reclosers must be operated manually or remotely executed command. So, here comes the distribution automation. If this recloser declares the fault is permanent, then the recloser must be operated from the remote station, from this master control center of the distribution automation system. That is what the smart grid demands. It should not be manually, everything should be in automatic process. Now, we have electronic switches also in smart grid system, where we have electronic devices present, it can receive maybe small processor is present inside it, and that processor will receive the signal and it will do the desired work. That is where the electronic switches, static switches, and those switches basically helps in sectionalizing faulty sections of the feeders. Let us say in some part of the feeder we have some fault. So, what will happen? This switches will help in isolating or sectionalizing that particular faulty section from the healthy section. So, that is what the function of this switch is, so that we can save few of our loads which are connected to the healthy section, and also we should not allow the fault current to propagate to the healthy sections, otherwise the the devices will see huge amount of current. The current is very high during the fault condition. So, those the fault current should not propagate to the healthy sections, and the switches are operated manually and again or remotely executed. Again, as I said before this, the reclosures case. So, similarly we should expect in smart grid system our technology should be so fast and so should be so automatic, we should operate these switches also automatically. Now, this is how this a few points I have written how this distribution automation operates. Each of these devices must include IEDs. Without IEDs we cannot make the system distribution the automatic. Why? Because these intelligent electronic devices will basically gather the information from the corresponding devices like circuit breakers, reclosures or switches, or we have distribution transformers. So, from those devices IEDs will try to collect the data, and these IEDs will send those data to the center, computer center, main center, and support the required measurement, monitoring and control functions. Now, these IEDs communicate with the DA control system, that is what I call, and this is known as DA master control center. The information from the IEDs will be sent to the DA master control center. Now, this DA data concentrator collects data from IEDs, one or more feeders and forwards the data to the DA master. What is the function of this DA data concentrator? This data concentrator collects data from IEDs and it will send to the feeders, okay, one or more feeders, and forwards the data to the DA master control center. That is how the infrastructure already we have discussed. Here these are the devices, like we have capacitor, we have reclosure, we have distribution transformer, we have all these equipments and switches. So, this IEDs will send the data to this DA master control center. This is the DA master control center. So, basically this data are sent 2 to 5 seconds as far as the Scada systems are used. And in future also we are planning this PMU technologies. PMU technologies, PMU means phasor measurement units, and those devices are very accurate, and in near future we are also planning to deploy to place PMUs for collecting the data and to have a very good monitoring and control system. And also we are planning this NAND technologies for this AMI, which is used for the AMI we have discussed during our AMI part. So, those technologies can also be used for DA. So, today we will just keep our lecture here, and if we just come to the conclusion, we have started with the components and technologies of the smart grid system, and I started with the advanced metering infrastructure, and then we have started with like distribution automation system. There we could see that how we can make the smart grid more smarter with help of these technologies. Okay, thank you.